Hi, I'm Wes McCall with Geoprobe Systems. I'm a geologist with the company and have worked with the R&D group to develop the pneumatic slug testing kit. So if you want to do slug testing to determine the hydraulic conductivity with either direct push install, groundwater sampling tools, or wells, you have pretty much everything you need here except the computer. This is a typical setup for slug testing in the field with a screen point groundwater sampler. What I did this morning was advance this tool down to about 50 feet and retract the screen sheath and expose about 1 foot of screen. And we're just going to go through and run a slug test and quickly show you how the system works in the field so you can see how simple it is. You can see here the pneumatic head is installed on the probe rod with the screen point 15 in the ground down about 50 feet. We have here the low pressure tubing, all right, for our air source that goes over to the pump here. The transducer cable comes over and the cable connects to the data logger, which we have here, and then data logger to the laptop computer and software on the computer acquiring the data. Okay, so that's pretty much how simple it is. You can see if you're in the field working out of a car or truck, you can set this stuff up on the seat in your car and run your test and then drive to the next location, and you don't have to break things down and set it all back up again. So it's pretty mobile, pretty easy to run in the field. Okay, so what we'll do is we'll just pressurize the system, operate the valves and run a slug test, and we'll see if we can see how our results turn out. Okay, all right, so first let's check everything. I've leak tested and set up here, and now I'm ready to close the release valve. The transducer is down approximately 3 feet below the water table and it's stabilized. We observe it stabilizing on the screen here. Okay, so it's stable, and so we'll close the valve. All right, and this valve I'm going to close before I start pumping and pressurizing. And the pressure regulator, I'm going to close that. All right. And so next what I'm going to do is I'm just going to pump a few psi of air into the tubing with our foot pump. This is really about the hardest part of this job. Okay, so I've got about 30 or so psi of air in the tube system. This is closed. Now I'm going to open the inlet valve here. And all right, now I'll start opening the pressure regulator, and I'll have to turn it around a few times, and we should start seeing air come into the system. The gauge will go up. Okay, all right, there we go. It's going up to about 15 psi. I'm going to close the inlet valve and let it stabilize. You can see the gauge is now dropping a little bit. It went up to a little over 15 psi. Now it's coming back down and stabilizing. So what we're seeing now is we increase the air pressure in the rods, okay, and as we increase the air pressure, we push the water out, down through the rods and out of the screen into the formation. All right, and now it's stabilized at about 9 psi. Okay, so now I'm ready to start my slug test. So all I need to do now to initiate the slug test is simply open this valve quickly. Poof. And if you're real close, you could hit air rush out a little bit and see the gauge drop quickly. And then when you look at the computer screen, you can see the spike from when we put air in, air pressurization spike on screen. Then we let it stabilize. When we release the pressure falls, the water comes back in, you get the recovery curve of the slug test. Now you save this in a file, you've acquired your data, now you can model it and calculate the hydraulic conductivity of the formation. Okay, so you can see how quick and easy this is. It's very simple to operate. Do it once or twice in the field and you get to be a pro. Some of the reasons you want to run pneumatic slug tests to measure the hydraulic conductivity is so you can determine how quickly the groundwater can move through the formation. And this gives you a first order indication of how quickly contaminants can move in the formation. So if you're doing risk-based corrective action or monitored natural attenuation, knowing that information, how quickly the contaminants can move through the formation, is very important data for you. We've developed the slug test analysis software. It's an easy-to-use software system. You can take data that you've acquired with your pneumatic slug test system in the field
analyze that data using some simple math models using either the Bauer and Rice or the Hovorsliev model, and have your result know what the hydraulic conductivity is right there in the field. Makes analysis quick and easy, and you can get good data. The software allows you to print out all the documentation you'll need to provide reports to your client.
So to kind of recap, the slug testing is good data to know how quickly contaminants can move through the formation, so you can estimate a threat or risk for receptors at potential drinking water supply wells. Information you need to know for monitored natural attenuation, risk-based corrective action, and also very valuable data for designing and implementing your remediation system.